Chapter 9c looks at differentiation using the chain rule, which is often written like this. If, for example, I have this function and I want to find dy by dx, what you do is, say you had x to the power 5 and I told you to differentiate this, you bring the power down, so 5x to the power 4. You do the same concept over here. So you bring the power down, so I'm going to have 5, and then this whole bracket, 3x to the power 4 plus x, and then take 1 off the power 4. Except, one more step, you multiply by differentiating what's on the inside here. So if I've got 3x to the power 4 plus x, and I differentiate this, I'm going to get 12x to the power 3 plus 1. So I just multiply by that, take 1 off the power, x becomes 1. So now I multiply by differentiating what's inside the bracket. That's 2x cubed plus 1. So your final answer will be 5 into 12x cubed plus 1 into 3x to the power 4 plus x. We'll do another example. Say I have this. Y is equal to ln x all to the power 3, and I have to differentiate, find dy by dx. I take the power down, so dy by dx is equal to 3 ln x times by differentiating what's inside the bracket, so 1 over x. So my answer will be 3 over x ln x. Another one. Say I have this. Y is equal to 1 plus 3x, and I need to find dy by dx. I'm going to firstly rewrite that as y is equal to 1 plus 3x all to the power half, and then to differentiate, I bring the power down, so that's going to be half into 1 plus 3x. I take 1 off the power, a half, take away 1 is minus a half, and then I multiply by differentiating what's inside the bracket, times by 3. I can rewrite that neatly as 3 over 2, 1 plus 3x to the power minus half. If you wish, you could bring that down and make the power positive, otherwise you can leave it like this. We'll do a few more. If I have y is equal e to the power x squared plus x, I want to find dy by dx. I want to differentiate e to the power x. That will give me e to the power, if you differentiated e to the power x, you get e to the power x. So here, just imagine that this is x. You'll have ex squared plus x. Now you want to differentiate this thing in the middle. So that will be 2x plus 1. We can rewrite the bracket first. So y dash is equal to 2x plus 1 ex squared plus x. Okay, the next one. I have 2 to the power x plus 1 all squared. Same concept, 2 to the power x plus 1. And now I need to, and I take 1 off the power, that gives me 1. Now I need to multiply by the differentiating this, which will give me 2x ln 2. Last one, same concept. I want to differentiate, if I had ln x and I told you to differentiate this, you would write 1 over x. So let's just say y is equal to ln x, y dash will be 1 over x. So here, imagine this sine x is just x. So you're going to get 1 over sine x. Now you have to differentiate what's inside the bracket. Differentiating sine x gives you cos x. So your answer is this, which is cos x over sine x, which is cot x. Okay, so these were some examples. If you would like to pause the video and have a go at these questions, and then when you're ready, you can go through the answers. So if you had y is equal to sine 5x, and you want to find dy by dx, you'll have 5 cos 5x, and which we looked at previously. The next one, y sine squared x, I would rewrite that as sine x all to the power 2, and differentiating that, you bring the power down, so that's 2 sine x to the power 1, and then you want to multiply by differentiating what's inside the bracket, which is cos x. So that will be 2 sine x cos x. The next one, we rewrite that as x plus 1 all to the power half. You want to bring the power down, take 1 off the power, then you multiply by what's inside the power, which is just 1, because differentiating this gives you 1, so that's your final answer. Again, I'm going to write the 3 on the outside, so that will be cos 2x all to the power 3. To differentiate, I bring the 3 down, that's 3 cos 2x, and then take 1 off the power, so it becomes squared. We'll just put it in a bracket. Then we multiply by differentiating the thing that's in the middle. The differentiating cos x gives you minus sine x. However, I have cos 2x, so it will be minus sine 2x, and then I have to differentiate this 2x to give me 2. So your final answer will be minus 6 sine 2x cos squared 2x. You can write the cos first. Last few, I have y is equal to e to the power ex. Differentiating that will give me e to the power ex, and then differentiating e to the power x is just e to the power x. This could be rewritten as e to the power ex plus x, because I have the same base and I just add the powers. This one, you want to differentiate this. If you had ln x and you differentiated that, you would do 1 over x. So here you're going to do 1 over this whole thing. So 1 over x squared plus 3x plus 5. And then you multiply by differentiating what's inside the bracket. So that will be 2x plus 3. We can rewrite that as 2x plus 3 all over x squared plus 3x plus 5. And then we have this one. I'm going to rewrite that as 5x squared plus 1 all to the power half. I bring the power down, take 1 off the power, and then I multiply by differentiating what's inside the bracket. That's 10x, just 10x. Now the question says, find dy by dx at 4, 9. So I found dy by dx. I now substitute x is 4. 4 squared plus 1 to the power minus a half times 10 times 4. This will give you minus a half times 40. That's 80 plus 1 is 81, minus a half will be 1 over times the square root of 81 times 40. These two cancel out and you're left with 20 over 9. That's the answer. So dy by dx at that point is 20 over 9. And then lastly we have this question. It says x is equal to 2y squared plus y, and differentiate y with respect to x. Now notice how this question does not start with a y, it starts with an x. So what you want to do is differentiate dx by dy first. So just differentiate this bit with respect to y. You'll get 4y plus 1. And then notice how dy by dx is equal to 1 over dx by dy. So this is really important. So here, in order to get dy by dx, which is what they've asked me for, after I do this, you do 1 over 4y plus 1 to get dy by dx. So if you have a function x is equal to some function of y, differentiate it with respect to y, and then do 1 over in order to get dy by dx. We'll look at one more example. Find the gradient of x is equal to, so notice how this says x is equal to this, when y is equal to 1. Now what you want to do first is dx by dy. So you bring the power down, so that's 3 plus 2y squared, and then you multiply by differentiating what's inside the bracket, which will give you just 2. We can tidy up. That will be 6 into 1 plus 2y squared. And then you substitute y as 1. So you'll get 6 into 1 plus 2 squared, which is 54. But to find dy by dx, you want to do 1 over whatever you've got. So 1 over, in this case, it wasn't just your function because you had to put in y as 1. So 1 over 54. So the main thing to remember is with the chain rule, you bring the power down, you take one off the power like you would do with normal differentiation, then multiply by differentiating what's inside the bracket. And the other important note to remember is when you have some function x and they tell you find dy by dx, you differentiate with respect to y and then you do 1 over in order to get the dy by dx.